Okay guys, welcome to your video tutorial looking at extending our knowledge on index law. This is the first part. Today we're going to have a look at using the power of a power result. It seems a bit weird, but go with me. It's common to find expressions in mathematical problems that contain more than one single number or variable, and they are connected by multiplication or division, and then they're raised to a power. These expressions can also be simplified, like we have in the last few lessons, by using index laws. We're going to use two of them, which effectively remove the brackets, like we've been doing the last few lessons. Okay, so let's have a look at what this is that I mean. How more than one number can be connected by multiplication and division, then raised to a power, and what it is that we actually do with it. Okay. We're asked to expand the following, and we've been given three different examples that I have here. This says 5b to the power of 3. This time, I don't just have one number or a pronumeral inside my brackets. I have a number and a pronumeral. Okay, so I have 5b to the power of 3. I know that this indice is on the outside, so it means everything on the inside to the power of 3. This is the same. 5b to the power of 3 is the same as saying 5 to the power of 3, and then b to the power of 3. So 5 to the power of 3 is 125, and then I leave b the same because I don't know what b is. So my answer of 5b to the power of 3 expanded, as this is asking me to do, is 125b to the power of 3. Okay, let's look at this next one. Negative 2x to the power of 3y, all of that inside the brackets to the power of 4. Guys, these look complicated. They're actually they're really quite easy. Okay, do them one at a time. So, negative 2 to the power of 4, that's the first thing. Then it's x to the power of 3 to the power of 4, okay? And I know when I've got a power and I'm putting it to another power, last lesson I learned it was multiplied. So it's x 3 times 4, okay? Then I've got y, now it's y to the power of 1, and I know and I'm raising that to the power of 4. Okay. Cool. Negative 2 to the power of 4. That's the same as saying negative 2 times negative 2 times negative 2 times negative 2. Okay, this is taking us back to our first lesson. Whenever I've got a negative to the power of 4 or 3 or 2 or 1, I work left to right. Negative 2 times negative 2 becomes positive 4. Because there's a negative and a negative, okay? So my running total is positive 4. Positive 4 multiplied by negative 2 is negative 8. Negative 8 multiplied by negative 2 is positive 16, okay? So negative 2 to the power of 4 is positive 16. Okay. X to the power of 3 to the power of 4. I know when I've got an indice and I'm raising it to another power. Last lesson I learnt that I multiply my indices. So that one will be x to the power of 12. And then I had a y in there with no indice. That means to the power of 1. So 1 to the power of 1 to y to the power of 4. 4 times 1 is y to the power of 4. So my answer for negative 2x to the power of 3y in brackets to the power of 4 is 16x to the power of 12 y to the power of 4. This last example here, it's interesting to note the 4 is on the outside of the bracket. So the first thing I do is my 4 is separate. It is my c to the power of 2, d to the power of 3 that's been raised to the indice of 5. It is not the 4. So my 4 goes down straight. Then I've got c to the power of 2 to the power of 5. So that's the same as saying c 2 times 5. We're dealing with everything separately. Okay, it's a bit of a dodgy times. Oh, let me write that again. Okay, I've got a c to the power of 2, and then I'm trying to put that to the power of 5, so I know my index law tells me that I multiply my indices. Okay, then I have d to the power of 3 to the power of 5. 3 times 5. Okay, so my answer for this one becomes 4c to the power of 10, d to the power of 15. And that's it, guys. That's using the power of a power to find a result. And dealing with more than one variable connected by multiplication and trying to raise those to a power.